So hopefully you can see this. There's this link here that has a couple of PDFs and an R script file as well as a CSV file that we'll be kind of working on. And yep, I will put that link in the chat. Give me a second. Okay. Hopefully it's a bit.ly link. Let me double check it as well to make sure that it's working okay. It should be. If anyone has any problems, let me know. So let me maybe share that screen as well. So it should look like this. It's in a box folder. There is a PDF of the slideshow presentation. There's a PDF for the R colors, a reference file. There is a CSV file of a data set that we're going to be kind of taking a look at. There's a ggplot cheat sheet PDF. And finally, there is a key R script file that we'll be using. So really the key files here are the CSV file, the surveys_complete, and this R script file, this DataViz in R workbook. So if you could download these and just kind of keep them safe, we're going to be kind of using them today. If anyone has any issues, let me know. I know this is a little bit awkward, just doing things virtually, and this especially being a workshop. I see someone raise their hand, and is there any questions in the Q&A? I saw that someone raised their hand. Oh, Autumn, is there any issues? Can't really see.
I can allow Autumn to talk if you'd like.
Sure.
Okay.
Autumn, do you have any questions, any issues? I'm not seeing anything in the question answer.
Can you reshare that link?
Yeah, yep.
Thank
Got
you.
it. Okay. Here's the link again. Oh, here's the link again. Give everyone a minute. Okay, great. Let me go back to sharing the PowerPoint. Okay. Okay. Does anyone have any issues? If not, we can get started. Once again, sorry, I know this is a little bit awkward being virtual. I know everyone should have gotten an email earlier this morning asking you to install R as well as RStudio. It might be a little bit difficult to troubleshoot if anyone has any issues with that, but hopefully all of you have R and RStudio installed on your computer or laptop, and hopefully it's working. If there's some issues that we can't resolve, definitely reach out to me afterwards and we can talk about the material and kind of getting things squared away and everything that you need. Yeah, so the email should have gone earlier this morning. I think it came from the Research Commons. Let me quickly link or show you, maybe show you where to go to get that if you did not. So let me go back. here. So if you do not have R and RStudio, you really need to have them installed on your computer for this workshop. I'm going to be basically doing a short presentation, hopefully short presentation in the very beginning, talking a little bit about R and RStudio, but the majority is basically taking a look at the R script file and kind of following along, kind of showcasing and demoing how to create a visualization using R. So here, R, you can get R at this link, this cran.r-project.org. And so you need to install that first. And then you need to go to this RStudio link here, and then download the appropriate version, be it for Windows, be it for Mac OS, or be it for Linux. So these are two things that you do need to have installed before we kind of get going with this workshop. I saw that there was a Q&A. So do the CSV and R files need to be in a particular directory, or does it not matter? So yes, they need to be in the working file folder, I believe. So hopefully just put them in wherever you downloaded them for now, but hopefully I'll kind of cover this. So when you set up R and RStudio, you need to specify a working directory, kind of where it defaults saves your files to. And the best practice is to put those files, the CSV file and the R script file, in that working folder. So remind me if I do not, because that's definitely an important thing to get things set up. And let me quickly type an answer to that. Okay. Any issues that anyone has? Once again, if for some reason you can't get things working and ready, reach out to me afterwards, and I'll definitely help you out to kind of get caught up with everything, even if we have to kind of go over some of these things again. So hopefully don't be too frustrated. I know this is a kind of difficult to do right now. Yep. So Alexander is asking about, do we need to specify a working folder, or it's not asking me to, which I do, I'm using an iMac. Let me hopefully get through this and show you how to set your working folder. It's definitely in RStudio. There's a little button there that you need to know where to press. And hopefully it's the same with Macs. So, okay, let's get started. Yeah, let's get started. Let me go all the way to the beginning. Okay. Well, welcome to DataViz in R. This is a pretty introductory workshop. It's a 2-hour workshop, but I'm going to kind of try to get through it as fast as possible. My name is Lian Cheng. I'm the data visualization specialist at the Research Commons. I'm actually fairly new to R. I probably have been only using it for about a year now. So I had no programming background at all. So this is kind of hopefully encouragement if you don't have any programming background, that you can pick up R, that it's a little bit challenging, but it's not that bad once you get going. And once again, I'm kind of prefacing that we're kind of speeding through or skipping through some of the basic R programming ideas that you probably should eventually learn, so that we can really get to the visualization part. And so there's some key concepts that I'll mention and I'll maybe demo, but just realize that I can't cover everything, and I'm trying to really get to the visualization part as fast as possible, so that you kind of get a sense of what you need to do in order to create a visualization if you have your own data set, and what kind of visualizations you can create using R. Okay, I saw there are more chat questions. Someone's asking, is R tools needed? I do not think so. I'm not exactly sure what R Tools is. So there's two things that you need to install: R from CRAN, that link I'll go over again, and then R Studio. And yeah, and there's some instructions that Brian posted up there that you can just link to and kind of learn how to install both of them. Okay. So a couple things, agenda and goals. So we're going to cover all these things. Why should you learn R for data visualization? How to install R in RStudio, which we've kind of already talked about a little bit. We're going to take a look at the RStudio layout, because that's really what we're going to be working in. We're going to cover some very basic concepts of R. We're going to create a variety of data visualizations using R, more specifically the package called ggplot. And then we're going to learn how to do some formatting, how to save and export our visualization so that we can put it in, say, a PowerPoint presentation. We can put it in a publication, on a poster presentation, in a PDF, etc. And then hopefully I can share some R-related data viz tips, or data viz tips in general, talk a little bit about some tools and resources and where to go from here, because really this is just kind of the beginning in terms of your journey of how to learn how to create visualizations using R. Okay, so why learn R for data visualization? Here are a bunch of visualizations all created in R, and hopefully they showcase a little bit about the diversity of visualizations you can create. So you can use geographic data to create maps. You can do these types of heat maps with time elements. You can do more traditional here grouped bar charts. You can do kind of more traditional these bubble charts. You can do a text frequency or text bubbles, these types of things. So there's really a wide diversity of visualizations that you can create, and you're not really limited too much in terms of what your visualization looks like and what you can do with it. And one of the key resources that you should really look at as you kind of learn R and create some visualizations for your own work is this R Graph Gallery. And so this website is sort of, probably would call it an encyclopedia for different visualization types. And what's great about it is it's divided by the function of a visualization type. So if you are using a scatter plot, it's basically, categorizing by, oh, what do you want to show? Do you want to show a distribution? Do you want to show correlation in your data set? Do you want to show ranking? And I believe there are more below. And so this really kind of gives you a good sense of why you want to use certain visualization types for your own work, and kind of how to go about exploring what are your options, what are the options out there for you. And more specifically, what's great about this particular site is that when you go into one of these kind of entries, these specific visualization types, it'll give you multiple examples of real visualizations created using R. And so if you're interested in this circular bar graph, this grouped one, there's a sample code that gives you exactly how to create this example, this circular bar graph. And you can, and I won't kind of guarantee that after this workshop, you can kind of take a look at this code and read it and understand it, but hopefully you'll have a starting point of where to go from here in terms of trying to replace some of these, this data with your own data to recreate it, or change colors and change shapes, etc. So there are a lot of other reasons why you might want to use R. R is a free, open source, and cross-platform tool, programming language, and it's under the GNU General Public License. And one of the big strengths is the reproducibility. And the reasons why R is used in academics is reproducibility. So R isn't some type of point and click where you need to know specific tools and how and click things in a certain order. It's not really like Excel in that way, or say Adobe Illustrator if you're trying to create some infographic, it's all written in an R script. So everything's recorded step by step. And it can be, there's basically a history to the way you go about changing your data and creating visualizations using your data. And this kind of step-by-step recording script can be inspected, it can be shared, and you can look back on it and correct things. You can apply the same steps that you did for a certain visualization next year for a new set of data that's very similar to your old data. You can apply, stylistic themes to your visualizations from one year to the next, or from one project to the next project. So that's what's so great about R in terms of reproducibility, is the fact that you can kind of look back and recreate things and adjust things, yeah, like that. R also works with all kinds of data and is designed for data analysis in particular. So R is a programming language, but it has a special kind of skill set in data analysis and data visualization. So in that way, it's a little bit different from more traditional programming languages, Python, Java, C++, things like that. There's also a large community with R, and there are many free resources. So you can take a look at communities such as Stack Overflow, RStudio, the RStudio community. And so if you have questions, if you have things that you want to ask or don't know about, there are other communities besides this workshop, and the local workshops around here are books that you can go to. And finally, there's just a huge amount of control that you have with R in terms of choosing colors and fonts and visualization types and kind of spacing and shapes. And so there's a lot of opportunity and control to create high quality visualizations. Okay, so installing R in RStudio. Hopefully you've already done this. These, again, are the two kind of tools that we'll be using. R is it's both a programming language and the software used to interpret the scripts that we're going to be using in writing. So it's you can download it and install it here at this cran.r-project.org. RStudio is a little bit different. It's called an integrated development environment. And so this is the tool, the GUI, the graphic interface that we'll be using in order to make it easier for us to use R. And so the link is here at RStudio. Make sure you download the appropriate version for Windows, Mac, or Linux. And finally, the instructions, if you're still a little bit confused about what you need to download, you can go to this link here and download or take a look at the instructions there. It should be pretty clear. So let me quickly take a look at the Q&A to see if there's anything else. Oh, let me take a look at chat. Okay, I think we're good. Okay. So RStudio, free open source tool. I mentioned before, it's an IDE. It's the graphic interface that we're going to be kind of using today that utilizes R. It's what we're going to be using to write our code, navigate our files, create and load our data set, manipulate and make adjustments to our data, and create visualizations. Now taking a look at RStudio layout. So this is what RStudio looks like. Again, we're going to be taking a look at this, opening it up. There's basically 4 main panes. There's this source window, which has our script. So here, when we open up that R script file, it's going to open up right here in the source window here. There is a console. So anytime we execute our source or run our code, it's going to run through our console here. And it's going to show up here. And any results are going to be kind of spit out here as well. There's also an environment or history panel or window here in the top right. And this basically, anytime we load up our data sets or load up, create variables, it'll show up here. It also has a history of all our steps. And on the bottom right, it's our files, plots, and packages, our help area as well. So any this is basically where our folder, our directory, our files are, and any visualizations that we create and run through our console are going to appear here as kind of a preview. Packages are also very important. So packages, we'll talk about a little bit more, but any package that you install and utilize, you can kind of take a look here, and there should be a kind of listing our library of all the packages that you have installed. Okay, so source, scripts and documents are our script files, environment history, workspace, command history, console, where our code from our script is executed, plot files, plots, and packages. Plots show up here, our packages are here, help is here. A very quick overview. About our packages. So today we're actually not going to be using the R's kind of default or base functions for visualization. We're going to be using probably the most popular package for R, which is ggplot. This is specifically for visualization, and ggplot is, or ggplot2, it's part of a collection of packages called Tidyverse. Super popular kind of set of packages that kind of extends the ability of R. There are many packages out here. Here's a link to some of the other ones that you can see. There's dplyr, there's tidyr, there's a whole bunch of others that can do different things, from manipulating your data set and cleaning it up to extending some functions for visualization, or allowing you to create visualizations that you normally wouldn't be able to create. And all these should be, most of them I think are free. And so we're going to be making use of these packages. Okay, hopefully you have all these files. Again, the key ones, two ones that we're going to be using today are the surveys_complete.csv file. That's the data set that we're going to be loading up and then creating some visualizations. I'm going to be challenging you to create some visualizations using this particular data set. The second one is this top one, this data_viz in R workbook. This is an R script file that we're just going to be opening up. It's going to open up in RStudio. And it's a little bit of a step-by-step. Both of us are going to go through it, and some of the challenges, visualization challenges to you, are part of that script file. Okay, here are just okay. I can save this for the end. So here are just more resources that I will talk about at the very end. And now we can just jump into RStudio. So let me do this. Okay, so let me open up that R script file. So if I share this, let me share just the screen here. So right now I have opened where I downloaded. All right, let me do this. So I'm going to open up RStudio, and I have it installed already. So when I open up RStudio, it looks like this. And let me go back to share. So you can go ahead and just open up RStudio. Looks like I have something already here. What I'm going to do is let me open up. Yeah, let me just go and open up. What's the best way to do this? Let me first maybe show you how to set your working directory. So someone was asking about this. So the best practice really is to have your script files, your data sets, your visualizations in your working folder. And I see there's a Q&A. Yeah, someone's asking about sharing the download links again. Let me quickly go back to chat to share that. So the download links are right here. Okay, hopefully you have that. So setting the working directory. So basically it's right here. So in the files, plots, packages, help viewer, if you go to more, you should be able to go to wherever your so mine should be on desktop. Let me see if I can find it. Maybe it's easier to actually exit this. Maybe it's easier to actually just go to, yeah, I think it might be easier to just go to wherever you saved your R script file and just double click that. Let me see if I can get this working. RStudio here. So this is what I have. When I double clicked the R script file, it looks like this. The script file is right here. Hopefully everyone has something that looks like this. I already have my working directory set correctly, but you might not have it set correctly. It might not be an issue. If it is an issue, let me know. But basically, you want the best practice, and I'm not sure if it causes any issues right now, but the best practice is to have your R script file, any output files, any extra data sets, etc., in the same working folder. And so I have it here on my desktop. It's in a folder called DataViz in R. And if you go to that particular directory through here, using the directory navigation here, you should be able to set as a working directory wherever you go into. Hopefully that makes sense. It's a little bit confusing, I know. I don't think there should be any issues with this for now. Just double click the R script file and hopefully it opens up and it looks like this. I think we should be fine for now. Any issues? Okay, if any issues come up, mention it in chat and I'll try to get to it. Okay, so hopefully everyone, where is default app setting page? So someone's asking about where is default app setting page. I'm not exactly sure what that is. If you're asking about where to set the working directory, it's right here in this little more section. So basically you would have to navigate to wherever the folder that you want to set as the working directory, and then you just set as working directory. And it should say here that basically it executes it in the console here and sets this particular directory, DataViz in R. For me, it's a folder called DataViz in R. Okay, someone mentioned that my RStudio is downloading a lot of packages. We do have to install some packages. I'm not exactly sure why it's installing a whole bunch right now. For new installs, we need now to install the dependencies for the R file. Okay, so okay. I haven't installed this initially for a while, so this came up when I was trying to open the DataViz file. I have a feeling, Bhavna, that maybe you don't have both R and RStudio. It just doesn't know that that file is an R script file and it should be opened by RStudio. So maybe open up RStudio. If you do have RStudio installed already, open it up, go to File at the very top and try to open that script file. Okay. Now there's a lot of technical difficulties here. Okay, hopefully we can get started. So basically this is going to be a follow along type of workshop. This has all the script and code kind of written out for us. And normally you would have to type out the code, but in this case, to kind of avoid any mistypes or kind of things that might slow us down, everything is sort of, all the code is sort of written out with a lot of different commenting as we go along. And so we're basically going to be going through this script. I'm going to be teaching a little bit about some of the coding in R, and we're going to create a bunch of visualization. I'm going to give you a few challenges to create some visualizations on your own after we kind of go through a few ourselves. And hopefully by the end of this, you have some practical experience trying to create a visualization in R using ggplot. Okay, so one of the main things that you do need to know is that we are going to be executing lines of code, and there's a kind of shortcut to do this. One of the shortcuts here is to use Alt-Enter. So here I have some lines of code. They're basically just calculations. And I can actually highlight each, say, one of these lines and execute this line of code. And it should show up on the bottom here in the console. And the way I do it is I highlight that line that I want to execute, I want to run, and I use a shortcut. I use Alt-Enter. And you can see here, 3 + 5 = 8. It ran this one line of code for me. I can kind of go through each of these lines and execute it without having to, type anything out. So this is kind of what we're going to be using in order to kind of slowly execute each line of code and see what it does. On Macs, I believe it's Option Return or Option Enter. You're going to have to correct me if I'm wrong here. Okay, Ken has an issue. It keeps telling me RStudio has stopped working when I double click on the DataViz in R workbook R script file. Stop working. Unfortunately, I'm not exactly sure. So this is a little bit difficult for me to kind of troubleshoot. I think my best answer for you is to kind of contact me afterwards to go through it kind of one-on-one. It's definitely a little bit more difficult to do this virtually. Sorry about that. Okay. Okay. So hopefully you know how to run lines of code now. It's basically you highlight the line of code that you want to run and you press Alt-Enter. And then you should see at the very bottom on the console, it ran that 3 + 5, it gave me 8. Anything that you see here with the what do you call it? The numpad symbol, that is comments. So I could select this entire thing, comment here, and press Alt-Enter, and it's just going to repeat it here, and it knows that it's just comments. It knows it's not really code, and so that's fine as is. So RStudio, it's very basic in that it can act like as a calculator. So you can do math, with it. Does addition, subtraction, division, multiplication. Here, I'm just giving you a couple examples that hopefully you can just run each of these, or you can just select them all together, press Alt-Enter, and you can kind of run all of them in sequence. We can also assign values to objects or variables. So in R, objects and variables, they're the same thing. So in this is how we assign them. So I can assign 55 to the variable, to the object weight underscore kg. And so here, if I want to select this, I can select the entire thing because I know this part is commented out. And if I run this, I basically create a new variable here. And if you see here in our environment, there's a new value called weight underscore kg, and it's 55. And then this actually just assigns it, right? Assigns a value to our variable or object. We need to recall it to see what it is. And so the second line just recalls it. And so weight kg is 55, we see at the bottom. So pretty straightforward, pretty simple. This is very basic kind of programming stuff. Similar, I here assign the number 3 to the variable x, or the value x, or the object x here. And it shows up here in my value section in our environment. And then we can use that as well. So I can say 2.2 times weight underscore kg, and it should give me that calculation. It's 121. So perfect. That's variables and objects. Pretty simple. One of the kind of fundamental aspects of programming languages. Functions and arguments. And so function and arguments are probably the most important other basic thing that I want to teach you and show you here. So functions are canned scripts that automate a set of commands. R has its own built-in functions, but R packages can be installed and loaded to allow for more complex functions. So here's a very typical example of a function. This is a square root function. And anytime we have a function, it has these parentheses because we can put stuff in it. We can put arguments in it. And so if I run this square root without anything in the parentheses, it's going to give me an error because it wants me to put some type of argument, something inside of it. So I can put 10 in it, square root of 10, and I can execute it. I can press Alt Enter. I can press Alt Enter. And here on the bottom, square root of 10 is 3.162278. So perfect. So this is really important to know. We have functions with the parentheses, and the functions, sometimes you need to put arguments in them, and sometimes you need to put multiple arguments in them. So here's another function, round. This is a rounding function. And so when I do round and I put a number in it, it's going to round it down to 3. So when I run this, it's going to round 3.14159 down to 3. I can put a second argument into it, and I can say round it down to two spaces, two digits here. And when I run that round function, it's 3.14. So this has 2 arguments that I can put in. I can put in only one, and then it'll default to setting this digits argument to 0. So functions and arguments. Another kind of very foundational thing within programming languages and within R. And this is going to be very important to know what's a function and to be able to know what's an argument and what you need to put into a function to make it work, to make it run. So one thing that is kind of key to know is if you're having issues, if you see a function or if you see a function that you don't know what it does, you can kind of get some help in terms of, okay, this is what this function does. These are the arguments I have to put into it in order to make it run. And so, for example, one place we can go to get help. So if I see this round function in that R gallery line of code, and I want to know kind of what it does, what arguments do I need to put into it, I can go to this help tab here and this eyeglass here, and I can go search for round. And it'll give me a description of this function. This is rounding of numbers. It gives me a description here. It tells me here what arguments do I need to put into it in order to make it work. So like we saw before, that I need to put some type of numeric vector here. And I can also specify the number of digits, the number of integers indicating the number of decimal places or significant digits to be used. And so if you ever have questions in terms of what does the function do and what arguments do I need, this is one place to go. You can also, okay, so we have it here. You can also use another way to do the same exact thing is just do a question mark in the console and do round. And it'll automatically kind of give you some suggestions. And when you do question mark round, it should pull up this exact page on the help section. So I can do this in the console. I can do question mark square root, and it'll bring up square root here. Okay. See any quick questions? No. Okay. So we're going to skip over some other concepts, including vectors, subsecting vectors, data frames, indexing. These are all really important in terms of prepping your data set and doing any cleaning and manipulations you need to do in order to prep your data set for visualization. I don't want to kind of undersell it because it's a super important part of data visualization, the cleaning and prep part, but I really want to move towards just visualizing stuff right now and showing you how to do that. You can learn about all these things, and a lot of this particular workshop is based off of this data carpentry workshop. So if you want to learn a little bit more about the prep work that you need to, and the foundational ideas that you need to know to kind of manipulate your data and clean it up and do things to it to prep it for your visualization, this is kind of the link to go to. Okay, so tidyverse and ggplot. I mentioned before that tidyverse is a collection of packages. ggplot is one of those packages within tidyverse, and it extends the capabilities of R. I provided some links here, so if you want to take a look at the multitude of packages that are available, you can take a look at this link. There's literally thousands, maybe tens of thousands of packages available that you can do different things with your data set. Tidyverse, the link to that is here. ggplot is an R package specifically for data visualization. And one of the key aspects of it, it follows this philosophy called grammar of graphics. And grammar of graphics is basically you're building up your visualization, your plot, by combining individual components. So you have your data component, you have your something called aesthetic mapping, where you're specifying, say, your what's going to be on your x-axis, what's going to be on your y-axis. You're specifying something called a geometric object, which is kind of your data visualization type. Is it going to be a bar chart or a line graph or an area chart or something else? So we're going to be using ggplot, which is in addition to R. It's not the default R visualization set of tools. So in order to do that, we need to actually install tidyverse and load it up. And so installing any type of package, you need to know this particular function, install.packages, and then in quotations, whatever that package is. So this line here, I'm going to run it. It's going to install down here. It's going to say, it's going to install my tidyverse set of packages. And this second line, library, it's going to load up tidyverse. So I'm going to run that right after. You can run them both at the same time if you want. And it should be fine. Here are the attached packages. You can see that ggplot is part of this tidyverse set of, is a package within the tidyverse collection of packages here. Yeah, so one thing here is in this packages tab, you can also see that hopefully when you go down to here, ggplot is checked off, meaning that it's installed. You can see what other packages have been installed here. Okay, so accessing our data sets. There's two main ways I want to teach you how to access your data set. One of them is using RStudio's built-in data sets. So just as a learning kind of tool, RStudio has a whole bunch of data sets built in. And so learning how to access these data sets will allow you to kind of Google a lot of different examples because people are using the data sets that RStudio has built in. One of them is this one called mtcars that we're going to be kind of taking a look at. The second way is how to read and load a CSV file. And this could be an Excel file or any other type of data set, data file. But in this case, we're going to do a generic CSV file. So the very first way, how to access mtcars, one of the built-in data sets. If you run this data in parentheses, this function, you don't put anything in it, it will give you a list of all the built-in data sets that are and any R package that you've loaded up have and are available. So I'm going to run this data in parentheses, nothing in it. And here are all the data sets within R, built in within R. And here are some of the data sets that came along with some of our packages that we just installed. dplyr, ggplot has a bunch of built-in data sets that came with ggplot when we installed it. And if you see here, mtcars is here, right here, motor trend car road test. This is a data set within built-in within R. So when we go back to our R script here, I can load up that data set by using the function data in quotations, calling up mtcars. So this is loading up mtcars. You'll see it should appear here on the console on the bottom, and it should appear here in our environment. It's been loaded up, mtcars right here. And if we want to see it, if we want to call out that data set, we need to actually, call it out. So mtcars will call out that entire data set. It's not a very big data set here. On the bottom, we've just called out that data set, this mtcars data set. It's not a very big data set. One way we can take a look at it, so this is a little bit difficult. I can obviously, adjust this to take a look at this particular data set. But here, it appears right here, and I actually can just left click it. A new tab will appear in the upper left, giving me easy access in a tabular format to this mtcars data set. And we see here, what we have here is basically a bunch of car models. We have a bunch of information, miles per gallon, cylinders, horsepower, AM is automatic or manual, etc. So we can take a look at our actually data set in a nice tabular format right there. There are different ways to also take a look at this particular data set besides just taking, if it's a very particular, if it's a very big data set, it might be a little bit unwieldy. So there are different ways, kind of commands or functions that you can utilize to take a peek at what your data set looks like. So if we run something called head and then put mtcars, our data set in there, if we run that, alt enter, it will give us the first 6 rows of our data set. If we do tails, it'll give us the last 6 rows. If we do n row, it'll report the number of rows in this particular data set. So there are 32 rows in this data set, and there are n columns, there are 11 columns. So that can be very useful. Just kind of take a quick snapshot look at what your data set looks like. There's another kind of thing that you can do. So we talked about installing packages. This is a little bit of a side note, but if I have this, so I've already taken a look at mtcars. If I want to save mtcars as a CSV file, save it and export it, I can do so. And I utilize this package called Rio. So I need to install the package, I need to load it up, and then I can utilize it. I can do the actual export, what it was meant to do. And so I'm going to go ahead and do this. I'm going to install this Rio package. It's installing right now. I'm going to load it up. I'm running Rio, or loading up Rio right now using the library function. And then I can export. And so I'm going to export this mtcars data set, and I'm going to export it as an mtcars.csv. And so I talked a little bit about, setting your working directory. And so where this is going to export this mtcars.csv file is to your working directory. So I'm going to run this. And I'm going to show you that here. I'm going to show you right here that mtcars is right here. 152, yeah. It's just newly created mtcars.csv. And if I double click that, let me just quickly show you what that looks like. mtcars. This is mtcars. Pretty similar to what we saw before. Hopefully nothing, nothing mind-blowing, but it's good to know that you can just export these data sets built in as a CSV file if you want to mess around with them in, say, Excel or other programs. Okay, going back to RStudio. Okay, going back to RStudio, the second way to access the a data set in R is to load it from an external source. So this is probably what you're going to be with your own work, what you're most interested in. You have your data set as a CSV file. You're trying to load it up into R. And how do you do that? What we're going to do is we're going to actually load up a CSV file called surveys_complete.csv. I think we already have, so I just placed this here in case we didn't already do it, but I think we already installed tidyverse. We already loaded it up, so we probably can skip that. This is the command to read our CSV file and put it into, as we see here, we're reading it and we're putting into this variable called, or object called surveys_complete. And so when I highlight this and run it, you see here on the upper right, the surveys_complete is a data set that has 30,463 objects of 13 variables. It looks like it loaded up. If I left click it, I can see in a nice tabular format, this surveys_complete data set. It's fairly big, 30,000 or so rows. If you want to take a look at, I can quickly share with you what this data set looks like. I think I have it open right here. So this is the data set just in Excel as a CSV file. Okay. Someone's asking, from which location R got its source data file for empty cars? That is a good question. I'm pretty sure it's like it's a real data. I would have to Google to see where they're kind of citing it or linking, but I'm pretty sure, I'm not sure if all, I'm pretty sure most, if not all of the built-in data sets are real data sets from real sources. But yeah, I'm not exactly sure where exactly. This is some Motor Trends. I'm not sure if that's some publication or something, but that's a good question. It should be something that I can probably Google and find out though. Any other questions? I know we haven't gotten to the actual visualization very quickly. Let me see if we can kind of get a little bit further. Okay, great. Got it. Okay. So yeah, great. So we've very easy, that CSV file, we put it in. It's now called this object, this variable called surveys_complete. We see it in our environment here in, as a data set along with empty cars. I think we're good to go. Because we're going to be working with this surveys_complete file, it's good to know what some of these headers are. So if you kind of take a look at the headers, I'll kind of read what they are. So this is a real ecology type of data set. I believe it's a real data set. Oh, someone's having issues. For whatever reason, the tidyverse install package had non-zero exit status and failed. I would have to Google to see what type of error that is, unfortunately. Is it not loading up? Double check if it's not loading up tidyverse. Like if you check the packages window, see if anything has loaded up. Unfortunately, it's very difficult to figure out exactly what's the issue without being there in person. Can you go back to our script? I think I am missing something in inputting this data. Okay. So I think you should be able to just follow along and just execute like one by one these lines of code. Let me know if there's maybe it's something that you missed. Sometimes I've noticed that you have to, even though we installed tidyverse before, you might have to do it again. I'm not exactly sure why this issue sometimes crops up, but if for some reason you can't execute this this read CSV function, try installing tidyverse again, running these 2 lines of code, and then going ahead and doing this read CSV. Okay. Yeah, sorry for these issues. I know it's super difficult to troubleshoot. We can skip this. Basically, this is just showing you, okay, I can use this head function and this structure function to kind of get a sense of what this data set looks like. We know we can kind of take a look just through this nice table, what it looks like. Oh, am I not sharing the right? I might not be. Yeah, okay. I might not be sharing the right thing. You are correct. Right here. Sorry about that. Okay, got it. Sorry about that. So hopefully we are on RStudio right now. So what I was saying before is if for some reason you can't execute this read CSV command, this line of code, try installing tidyverse again here and then loading it up. Because for some reason, I've had issues sometimes where I know we've installed it before in a previous line of code, but for some reason it kind of gets lost. And I'm not actually sure why. So if you do have that issue, try installing tidyverse again, loading it up, and then immediately read CSV. Hopefully we're okay here. I'm going to skip this head and structure function that I talked about before. It's not super important. What is important is to get a sense of what this data set is. So this is a ecology data set. It has a record ID, so a unique ID for an observation. It has the month, day, and year of whatever observation was made. And so this was a data set where I think ecologists went to a plot of land, they caught some rodents, they recorded the day, month, year that they caught it, they recorded the plot of land where they caught that particular rodent. They have a species ID, they have the sex of the rodent, of the animal, male or female. They had the hindfoot length in millimeters. They had the weight, genus, species, taxa, and plot type, the plot of land, the type of land that it was on. So this is a real ecology type of data set. And this is really where I think we're getting into kind of the good stuff. I'm going to kind of quickly skip through this part because it's basically stuff that we've talked about already. Empty cars, the very first example of a visualization. We're finally at a visualization example. We're going to use empty cars here. This line right here is really the key aspect of beginning to learn how to use R to visualize, or ggplot to visualize your data set. So the very foundation is this ggplot function and adding some type of geom function. So I probably need to explain myself. So this ggplot function, you have two different, you can have multiple arguments in it. There are some key arguments that you put into this ggplot function. You need to specify where's your data set. You need to point it into the right data set. It might be empty cars. It might be surveys _ complete. Any of these data sets that we have loaded up already, right? Mapping, this mapping equals AES. This AES stands for aesthetics. So this mapping part equals aesthetics. Some people shorten it to just AES and then they put in whatever argument here. So I know this is can be a little bit confusing, but just call it mapping. I just call it mapping equals aesthetics. And what you put into here, this mapping section, is you can put a lot of different things. You can specify what's going to be on your x-axis and what's going to be on your y-axis. Sometimes you can also specify the color you want to assign things as, and other things. So that's what ggplot is. And then this addition here, I'm adding this second function here on the second line. So it's ggplot function plus a geom function. What a geom function is the type of visualization that you're going to be creating. So some examples. If you're going to be creating a bar chart, you're going to use this geom _ bar function in replacing this geom function here. If you're going to be creating a scatter plot or some type of a dot plot, you're going to be using this geom point function here, right here. You're going to be doing a ggplot plus this geom underscore point function. There are many different types of geomes. They're basically just visualization types. Okay, that's good. ggplot should already be loaded up. So this is just in case something goes wrong. So the very first visualization we're going to create is a simple bar chart. We're going to do it using mtcars. And we're going to basically be creating a bar chart that has 3 bars. Vertical bar chart. It's going to show that there are a certain number of cars in our data set that have 4 cylinders, 6 cylinders, and 8 cylinders. So you can see, if you go back to mtcar, you can see cylinders right here. In our data set of 32 cars, I believe, they only come in 4, 6, and 8 cylinders, right? So we're just basically doing a count, vertical bar chart count. So how do we do this? We call up our ggplot, and in our first argument, our data argument, we're going to tell it to go to look at mtcars. So data equals mtcars. Our mapping equals aesthetics. There's one thing we're going to specify. We're going to specify what is going to be on our x-axis. So on our x-axis is cylinder. So cylinder right here, this column right here. And so we have this ggplot function done. And what we're going to add is our geom bar. So it's going to be a bar chart. We're not going to put any argument in. So what does this look like? I'm going to execute this, and hopefully you'll maybe not be wowed, but this is the first visualization. We have our bar chart, finally, after all this work. Simple bar chart. We get our count of 4-cylinder cars, maybe, maybe like 12, 13, somewhere there. 6-cylinder cars, 8-cylinder cars. Simple count, simple bar chart. One thing that we can fix about this particular bar chart is that, you see on the x-axis that it's a continuous x-axis. But in reality, these are really categories, 4, 6, and 8-cylinder cars. And so one thing that we can do, and I know this is maybe getting a little bit slightly more complex, is we can fix that. And the way we fix that is using this new function called factor. So if we factor the cylinder, it will change it from a numerical value to this categorical value. So we can do that within the ggplot argument here. So the only difference that we did is that we put this factor cylinder and just replaced cylinder here. So take a look at what happens here. I'm going to execute this. And great. Our 4, 6, and 8 are now treated as categories. Perfect. So this is just one little thing that kind of, as you learn a little bit more, you utilize, and you can kind of fit it right in here. Okay, we can also utilize color. So that sounds kind of interesting. So in this case, we're going to do something very simple. We're going to color all 3 bars separate colors. So how do we go about doing that? We have our ggplot again. We're specifying here, we're referring to our mtcars data set, mapping equals aesthetics. We are specifying that our x-axis is going to be this categorized cylinder column. Our fill here is now going to be different. Our fill is also going to be factor cylinder. And so when we do this, it's going to fill these colors with whatever unique category this is. So one color for 4, one color for 6-cylinder, one color for 8-cylinder. And then geom bar, specifying that this is going to be a bar chart. We're not going to specify any special arguments within this geom bar function, and it's going to automatically know that it's whatever the defaults are. So when I run this, perfect. A unique color for each one of these bars. And this is only one way. Obviously, there are many different ways to kind of color these. This is just one particular way. So don't take this as kind of the be all end all of how to have 3 distinct colors in this particular bar chart. To kind of highlight a little bit of like how complex you can get. For example, if I want to create a colorblind friendly bar chart from this simple bar chart, one solution I can do is I can create a palette. So I'm not going to really get into creating vectors here, but here are 1, 2, 3, 4, 5, 6, 7, 8 different color. I went to a website. I got these 6 colorblind friendly. I got these colors from a colorblind friendly palette, and I assigned it to this variable, this object CB colorblind palette, CB palette. And I can utilize this object within what I created before. And I can do that same thing. I'm just copying exactly the ggplot, exactly same as before, geom_bar exactly the same before, and I'm just tacking on a new little function here called scale_fill_manual. So this will allow me to create my own discrete color scale, and I'm putting CB palette, which will take the very first 3 colors that I assign. So I'm manually assigning the colors here. And so this is what I talk about when I talk about so I'm going to execute this. Let me just execute this to show you what it looks like. Oh, I did not execute this top one. So I need to create the CB palette object first, and you can see the values right here. It's a vector here, and then I will run this line of code here, which so here are my 3 colors. This gray color, it's just taking the very first 3 colors here in this colorblind friendly palette. So this is what I'm talking about when I talk about grammar of graphics, where you have this ggplot function, and then you specify all your arguments with it. And then you specify the geom, what type of geom you're going to use. Sometimes you'll put arguments in it as well. And then finally, you tack on this new last function here that adjusts color, or the color scale, a particular color palette for your visualization. There's kind of these components that you put together in order to finally get this visualization. And you can swap out different things, right? I can swap out this geom_bar with a different geom and keep the rest of it the same. And so this is one of the reasons why R and ggplot kind of utilize this kind of philosophy of these components that you can swap out and change very easily. Question, okay, lots of questions. Or 2 questions, I should say. I had to join the course late. I'm wondering if we will have access to the recording after the course is finished. Yes, you should have it. Do you have any suggestions to find colorblind friendly palettes? You should be able to Google them. I think there are some particular websites out there, including there's one particular one that I can't remember off the top of my head, but I can find it for you. It's from, I think, UPenn or University of Pennsylvania, or one of the Pennsylvania universities. There's a kind of a well-known color visualization resource that people use. So take a look at that. I can kind of follow up if you have more specifics about it. Finally, are these palettes available for downloading? They should be, you should be able to find the code, the hex codes for them. So that's what I utilize here. I just copied them over. There should be several different types of colorblind friendly palettes out there. I can definitely the next thing I'm going to talk about is a little bit more about the colors. So here I showcase the hex numbers for each of these colors. If you want to be very specific and specify them by hex number, there are other ways to specify what color you want. There's in one of the PDFs that I gave you, it's called R color.pdf. And so if you take a look at that, it looks like this. Let me open it up. So it looks like this. And so R also recognizes names, certain names of colors. And so here is basically a list of all the named colors that R recognizes. So you can just put these in as well. You don't necessarily have to use the that hex number hex code for the colors. You can also go back. You can also utilize other types of color spaces. So it recognizes HSV values as well as HCL or RGB values. So there are different ways, and there's a link here to how to utilize these color spaces if you want to use just RGB, for example. So take a look at that as well. There are a lot of labeling options as well in R. So you can label different things, your x-axis, your y-axis, your title, your subtitle, captions, things like that. Here, I'm just showcasing some of these options. So this is in a function called labs, which stands for labels. And within labs, you can specify several arguments. You can specify a title argument, a subtitle argument, and a caption argument. And so here is an example where I'm adding everything up. I'm slowly building up this bar chart. I'm adding labels, and I'm adding several arguments within this label to specify title, subtitle, caption. And you can see how it's kind of formatted, title equals, and in quotation, whatever you want, and then spaced out by the commas. So I'm going to run this piece of code, and you can kind of see how this is starting to build up in terms of you have your title, subtitle, figure A, XY axis. So XY axis is our labels is next here. So they're their own separate function called XLab and YLab. And so here I'm just adding more to my visualization, grammar graphics. So here, yeah, X label, Y label, I just changed it to something a little bit more appropriate, number of cylinders and count on the Y axis. So we're done with that first one. We kind of built it up. You now have a sense of what you need to create a simple visualization. The ggplot function, and then a geom, and then there might be some other functions that you add on. Someone asked, where do you get these PDFs that you shared with us? So you can get them right here. Let me link it. So the PDF should be right here. Yeah, feel free to just follow up with me afterwards as well. Okay. Here is another another type of visualization, so stack bar chart. I'm going to kind of go through a little bit, kind of speed through this stuff that I'm not going to cover in detail. Basically, I'm doing a little bit of data cleaning in order to get the data set to be, for mtcars to be something that is usable for a stacked bar chart. So, okay, someone's asking, so if we want to assign specific colors to values, longer bars are red, example, longer bars are red, would we need to use specific functions and arguments, right? Yeah, I mean, you can assign things to, if you know exactly like in the order, okay, from left to right, this one's going to be red, this one's going to be blue. Like you can assign it in a specific order like that and say red, blue, red, red, you know, things like that. There's probably other ways to do it as well. Instead of just very simple, just in order, you create a vector that has the colors in that order and you just apply it. I'm sure there's other ways to do it as well. But you definitely you can do that. Like that's definitely an option. And you probably whatever's under the sun, whatever you can think of in terms of coloring, probably R can do it. It might take some creative finagling with different functions or creating different vectors and assigning different things, but you should be able to do it. There's a lot of kind of creative solutions, I should say. Okay, so I'm gonna kind of run this. This is using another package called dplyr, and I'm basically creating a adjusted mtcars data set here. I'm gonna run it here. It's basically going back to this AM column, is changing the ones and zeros to automatic or manual. And so this is the stacked bar chart that I'm going to create. So if someone has their hand raised, Could you type maybe what your question is in the Q&A if you have a question? That might be easier. Okay. Oh, let me see, question. Oh, yep, accidental hand raise, that's fine. So here in our adjusted, I'm going to just take a look at it. This is the change that I made in AM column. It's basically changed those zeros and ones to manual or automatic. And when I go back here, I want to create a stack bar chart. The key difference that I make here is that right here, I'm going to fill in my mapping equals aesthetics. I'm specifying that on the x-axis is going to be cylinders. So I have my 4, 6, and 8, and on my I'm going to fill these the colors of these bars with whether or not they are automatic or manual. This AM represents that automatic manual column right here. So you can see just this one change, this one argument, this fill argument, I can quickly create a stack bar chart like this. I can create it, I can change it into from 100%. So there's just one key difference here. I'm going to run this right for you. It's an argument within geom bar. So this is an argument that you're specifying the position to be fill in order to get this 100% bar chart. And so one of the questions you might be asking is, okay, how do I even know that, right? Like that's very specific. I need to maybe look into geom bars, see what arguments are available to figure this out. There's another kind of key, another thing that can help you is that cheat sheet, that ggplot cheat sheet PDF. Let me quickly show you so you can kind of get a sense of why it might be useful to you. Where is that cheat sheet? Right here. Okay. And right here. So this PDF is super, pretty comprehensive. And so if you look here, you can kind of get a sense of, what types of geomes are there. Here's some very simple ones. Here's some ones including just using one variable. Here's my geom point, right, for any points. Where's my bar? Bar should be somewhere here. What did I want to show you? I wanted to show, let's see, position fill. Let me go back. Where was it? Here. Well, bar is definitely here, and you can see in this cheat sheet, you can see geom bar for that function. Here are some of the arguments that you can include. You can include alpha, which is the transparency, color. You can change the fill, line type, size, and weight. The position I wanted to show you was this one right here. So position adjustments. So position adjustments determine how to arrange geoms that would otherwise occupy the same space. So this particular one kind of showcased how to do that percentage from 100%. Stack elements on top of one another normalizes height. So position equals fill. So this is a really good cheat sheet to really see what's out there. And I know it's probably a little bit difficult to find out exactly, how to do it, that, a percentage 100% bar chart, you would have to find it here. But this is a really good resource that you should utilize and get a sense of what the options are out there for each of these functions and what are all the arguments that you can put in. Okay. Yep, I will go back to RStudio right now. Okay. So we did this 100% percentage stack bar chart. We can also do stuff like make it side by side. And so this is another argument that you can take a look at in the cheat sheet. So we're going to put these as side-by-side bar charts. So this is this position argument, and you set it to position underscore dodge 2. We can put them slightly closer together so you can see a little bit, slight nuances, slight difference. We'll just have them slightly together here. If I want to go back to my previous, visualization that I created, I can go back here. So here's the difference between these two, that just slight gap between the bar charts. This is utilizing this position argument right here. Position dodge underscore dodge 2 versus position underscore dodge. So a lot of different options here. I did mention this before. Once again, if you're not sure like what position dodge is or does, you might be able to kind of put a question mark in the console and put position underscore dodge here, and it gives you some suggestions. And if I click this, I think, and enter it, it goes to the help here. So I can get a sense of what this position dodge thing does. So here, dodging preserves the vertical position of a geome while adjusting the horizontal position. So you get a little bit about some of the arguments. So you can even specify some specific arguments to this, this thing right here. And it gives you some examples as well. So hopefully you can take a look at some of these examples, execute some of these lines of code, and get a better sense of how to utilize this. Okay, histograms. Histograms are great at showing kind of distribution over some type of continuous period of time. We are going to take a look at empty cars. Very simple, nothing particularly super special, but the only thing we have to really do is swap out this geom and utilize geom underscore histogram. And so once again, we have our ggplot function. We're telling it that we want to utilize our empty cars, right, data set right here, data equals empty cars. Mapping equals aesthetics, we need to specify if anything is on the X or Y axis. So in this case, we're gonna take a look at miles per gallon and take a look at kind of the distribution of our cars by miles per gallon. We are going to add this geom histogram. So it's going to be a histogram. It's going to show distribution of these cars. And I'm just going to add some labels to make it add a little bit better context. So if I run something like this, I get something that looks like this. Not the prettiest kind of histogram, but you know, it shows what we want. There are a couple of things that you can do to this. You can adjust the number of bins that you have right here, right? So right now the default is 30 bins. So if I count 1, 2, 3, 4, all the way here, this is the 30th bin. There are 30 bins is the default here. I can change the number of bins. I can also change the bin width. So let's try some of this out. So here, where would you change the bins? You can change it right here in the bins, in the geom histogram portion, right? So if I change the bins to 5, this is what it looks like. There's only 5 bins. Okay, we get a very kind of general sense of the distribution. If we change the bins to 10, here's how it looks a little bit different. And then here's 30, and here's 50. So obviously there's a little bit of decision making. You need to use a little bit of your judgment in determining what's the best bin size to kind of showcase the observations you're making and that reflect kind of what you're seeing in this particular data set. Now, hopefully you kind of get a decent sense of the basics of using ggplot function, adding a geom, adding any extra labels or whatever. I'd like you to kind of get some practice. So I know after finally an hour and a half, we have some real life practice to give you. We are going to take a look at our surveys.csv file. Hopefully we should have already loaded up tidyverse and read that CSV file. Hopefully it's right here in your environment on your top right. And so in our very first challenge, I'd like you to, as an ecology researcher, You've collected this surveys underscore complete data. You're interested in seeing if there's any correlation or relationship between the weight of the creatures that you've caught in this field study and their hind foot length. So using ggplot, can you create a scatter plot to show this? And can you go ahead and assign this scatter plot to a new variable, a new object called surveys underscore plot? So take maybe 5 minutes or so, see if you can do this. The answer really is just, if you scroll down, the answer is down there. So if you just want to take a look at the answer, we're going to be going over it. I'll give you just a couple of minutes. I know we're kind of running late, and we're probably only halfway through this particular script. But let me maybe give 3 minutes for you to try to get a stab at this and try to think through it yourself. If you have questions, just write it in chat, but try this out. Okay, I know we're kind of strapped for time here, so hopefully you got a sense of how to do this. It's tidy. So someone's asking, is tidyverse necessary to open a CSV file? I actually am not sure. I don't think so, actually. I think there are actually multiple ways to open one. I don't think so, but that is actually a good question. I'm not exactly sure. So that's the read. Give me a second. I'll have to get back to you on that. Yeah, read underscore CSV. My notes, it says it's a function, it's part of tidyverse, but I would just kind of assume that there are other ways to do it. But I'll have to look at it. The way we did it, it looks like it specifically involves tidyverse though. Okay. Let me quickly get back. So our challenge, so this is how you do it. It's very kind of simple. ggplot, we're gonna use our ggplot function. We're gonna specify where our data set is. It's this surveys underscore complete. So if you notice, if I just execute this one line, it doesn't do anything, right? No plot here. We haven't specified the the other aspects, right? We need to add our mapping equals aesthetics, and we need to specify that on our x-axis is going to be weight, on our y-axis is going to be hindfoot. And again, these are the column headers, right, that we have in our actual data set here, hindfoot length, etc. And if we execute this, you should expect we still don't get anything that are a complete visualization, because we haven't specified what type of visualization type we're going to utilize. And finally, when we tack on this plus and this geom point function, we don't have to put anything specific in it, but we can kind of execute it. We finally get something that we're kind of expecting, right? Our plot, our scatter plot. On our x-axis, we have weight. On our y-axis, we have our hindfoot length in millimeters. And to assign this particular plot, this particular visualization to an object or a variable, we can just use this arrow dash and assign it to surveys plot. So when we execute this, we see surveys plot is right here. Okay. And then this kind of simplifies things, because if we use, okay, so the surveys plot is only ggplot. And so we can just utilize this particular object, this particular variable, and just add on whatever geom we want. So be it geom point or some other geom. So here we're just using geom point. It should be, I think, exactly the same thing. And then I can just swap it out with something else, like geom underscore smooth. It just looks a little bit different. I'm not exactly sure what kind of visualization this is, but we can just swap it out, swap geoms that easily. Okay, so one of the problems with this scatter plot, let me go back because this is not the one I want to take a look at. One of the problems with this scatter plot, I'm going to kind of rush through this a little bit more because I at least want to get to some of the other aspects. And so, yeah, let me kind of quickly explain some of this, these questions to you. So one of the problems with this particular scatter plot is that it's kind of overplotted. So this is issue that we sometimes encounter in certain data sets. Small data sets that have very few unique values have this overplotting issue. There are different types of solutions to it. So I kind of go through, I think, some of the solutions. And some of the solutions are formatting solutions, like adjusting dot size, maybe not so much in this particular case, and adjusting transparency. And the way you can do that is I'll go ahead to the answers and kind of show you how to do that. In order to adjust transparency, you adjust an argument called alpha. And alpha you can set from 0 to 1. 0 is, I think, completely transparent. 1 is completely opaque. So here we're setting our alpha on our points to 0.1, fairly light, I believe, so pretty transparent. So you should see a difference here. And notice that we're assigning the alpha to the geom point function. Yep, we see here, transparency is there. You can kind of go through some of these examples where the dot size is too small. I'll skip the too large. Maybe something like this is about right. And I'm also changing the size of the dots here. So here's another argument that you can kind of adjust, a second argument within the geom point function. So maybe something like this is more appropriate, where we see like kind of 4 kind of distinct groupings. This is a side note. There's some funky visualization types. So here's a 2D density chart that you can kind of play around with. It has its own kind of special arguments, but there's definitely an abundance of visualization types to explore. I'm going to skip this for now. This is how to do some sampling. So another way to get around overplotting is sampling, using sampling. You can also use jittering to try to solve the overplotting problem. So this is how you might add color to that scatter plot, that original scatter plot that we saw. You just add a third argument to this geom point, color. And here you see I'm just specifying blue. So this is what ggplot are kind of used as blue. I'll skip this hexbin kind of, this is just another package that allows you to do this geom hex function, this visualization type. Let me see. So here we're starting to get to some more kind of nuances in terms of applying color. So I'm using species underscore ID to color this scatter plot into based on species ID. So here I'm adding something new here. I'm adding this argument mapping equals aesthetic argument. I'm specifying that the colors are going to be based on what species ID there are. I think there are maybe like 13 or 14 species IDs here. And so they're just, each one has a unique color. And another thing that's kind of really good to notice here is that this species ID, this color kind of option, I can put it in geom point, the geom point function, or I can just bump it up into this ggplot function as well. So right now it is in the geom point function is an argument within the geom point function, but I can actually put it in the ggplot function as well here in the second example here. So I'm going to run this color equals species ID underscore ID, and right now is an argument within the mapping aesthetics of ggplot. And I believe it should just give me the same thing. And so this is, again, playing up to this idea of kind of the grammar of graphics philosophy that R and ggplot follow, that you have these different components, that you have these different arguments that you can kind of swap out and you can put at different levels, right? So here is an example of where this might be more apparent, maybe. Let me kind of run through some of these. I think this one involves some jitter. You shouldn't really see too much of a difference here. This is a geom called geom underscore jitter. It's very similar. I wanted to show you, kind of highlight what I was talking about before. I'm just going to quickly run through some of these box plots to show. So here's a box plot. The only, like, I'm specifying my data set. This is the survey is complete. Mapping equals aesthetics. I'm specifying what's going to be my x-axis, the species ID, the like 14 or so species ID. On the y-axis, it's going to be weight. And then I'm just making it into the geom is a box plot. So very simple, quickly get a box plot. I'm going to add something really interesting here. So I'm going to add a jitter layer on top of this box plot. So this is essentially two visualizations on top of each other. A geom box plot and then a geom jitter, or geom jitter is basically a geom scatter plot. This is what we get. So one thing that you'll notice here is that the box plot layer is below the jitter layer. And so that's why there's kind of levels here. This one is kind of drawn first, and then the second one is drawn on top of it. So we can kind of change the order of that, right? Just switch around the geom order. And this is what it looks like, the difference that kind of highlighting. Let me see. Before and then after. Just the difference between the layering of these geoms, these two visualizations, one on top of the other. Let me see. I'm kind of really speeding through this to see if there's anything else that's kind of worth talking about. I'm just running through these and running these lines of code. So this was a violin plot that I created. So there's a little part that I wanted to talk a little bit about violin plots and how they're different from box plots and why they're nicer than box plots. But there's some interesting, so in this, right now, what you're seeing here is this particular line of code. And it's supposed to highlight both violin plot here, geom underscore violin. Alpha is set to 0 so that there's no, I don't think there's any like fill within this violin plot. It's kind of transparent, totally transparent. Is this scale? So you can adjust scale as well. So before, if this is a logarithmic scale right now, but if I had it on a linear scale right here, this is what that looked like before. The violin plot with that kind of scatter plot on top look like this. So it's very difficult to kind of differentiate some of these smaller ones. So that's why I changed the scale here. So obviously you can change scale to different scales. And in this case, we're just adding a new function called scale underscore y underscore log 10. No arguments within it, and you just have to tack that at the end, and you can change the scale very easily. Okay. Time series. So I'm going to kind of just execute these lines of code to kind of be able to talk a little bit about them. You can take a look at some of them. I think these ones in particular are a little bit more advanced. But this is an example of like time, a data set that involves time from, this is again, the surveys underscore complete or rodent kind of collection. What am I doing here? So here I'm adding labels to it, X label, Y label. I'm annotating it as well. And so I'm kind of transforming this to add more context. You see title, subtitle, you see some labels, you see some color coding for the lines themselves. So I kind of expect maybe at this point that you can take a look at this visualization and you can take a look at this code right here, this snippet of code, and understand how they're related together, right? That ggplot, that it's referring to this particular data set. Mapping equals aesthetic, it's specifying what's going to be on my x-axis, this year column header, right? What's going to be on my y-axis? There's a new column header called n. Because so there's a new data set that I created out of this called yearly underscore counts. So the data set has changed. You should be able to tell I'm basing the color on the genus. So there's like, I don't know, maybe 8, 9 genus here, and each of them are colored differently because it's based on the genus. And you should be able to tell, okay, geome line, the size, the thickness of these lines is right here. The size equals 1. And it's a line graph because we specify the geome as line. You can be able to tell, the labels, the title is all here. X labels here, nothing's in it, so I didn't want to label this years. Y labels here, it's count. Count is right here, great. Annotation, so this is some of the new stuff. I'm basically adding a text annotation right here because I noticed that this particular genus has kind of skyrocketed over the years, the count of it. And then there's a rectangle. I created this gray rectangle just to highlight. This is very crude, but there's some like annotating tools, functions as well. Another really cool thing that I wish I had more time to kind of really talk about is something called faceting. So I'm going to really run through these codes. Faceting is super interesting. It allows you to create small multiples, basically. And so here's one way where I'm using a function called facet underscore wrap, and I'm doing it based on genus, and I get these 6, 7, 8 genus kind of all in the same scale of X and Y scale in small multiples. And we can really kind of jazz this up and create something really unique and interesting. So I'm going to run through all this code to get something. So here is another type of faceting method. This is using so there's 2 types of facets, one called facet underscore wrap and one's called facet underscore grid. And so just to show you the difference, here is wrap. So it's just going line by line like that. And again, before we had facet underscore grid, I'm just running it again. We have kind of side by side. Right now it's divided in male and female. So I actually did some manipulation to divide it and tease out between male and females. So facet wrap and facet grid. There's a lot of different options here that you can explore. Here's different setups, facet by row. You can also facet by column. There are themes within ggplot. So here is, you might not be able really to tell too much of difference here. Here's one theme. So you can see how it's kind of, there's this gray title box, there's these grids behind. So this theme is called black and white BW theme underscore BW. So it's just another function that you can add on, tack on at the end. And there's multiple themes. Here are some popular ones. So theme underscore minimum, theme light, theme void. So these are themes that you can try out, and they kind of change each of these to look a little bit different. Here's some examples. So here's the minimal theme. It kind of gets rid of a lot of different borders on the outside. Here's theme light. Here's theme void. So nothing. So a lot of different, and then there's more themes in this package. So hopefully you know how to install packages. You can install this GG themes package, load it up, and utilize the themes that are within it. What is this? So this was another challenge. That's fine. Okay, so kind of to wrap things up, we got 10 minutes left. How to kind of arrange and export your visualization. This is obviously very important. You've done your visualization, you're happy with it. You might have multiple visualizations that you want to put side by side. You want to export it as a PDF or a PNG or whatever file format that you want. It needs to be a certain size maybe. And you want to get a good quality so that you can put it in to be printed or published maybe. So in order to kind of lay out multiple visualizations together, like say side by side or in a more complex manner, there's a package called Patchwork that's very useful. So here we're going to install it. We're going to load it up. I'm doing that right now. We're going to use the empty cars, and we are going to basically create some plots here. So I'm loading up the empty cars in case it should be loaded already, but so there are two objects here. So there's two plots here. Maybe I should just P1 and P2. So let me maybe just show them. Here's P1, here's P2, scatter plot and a box and whiskers plot. So the way that Patchwork works is that I can do them horizontally put them horizontally side by side by using the plus. So here's my first, this was my scatter plot, and then here was my object variable for this box plot, this box and whiskers plot. And so when I execute this line of code, I have them side by side. You might be thinking, okay, this is a little bit stretched. We'll get to that later. I can also do them vertically. So I use the division sign here, arrange them vertically like this. Great, looks good. It's a little bit stretched, but again, I'll get to that. You can get more complex. So here is two more visualizations, P3 and P4. I'm going to arrange them in a really nice, complex kind of way. So I'm going to put P1, P2, and P3 on the top side by side, and then P4 on the bottom by itself. So I can arrange it in this particular line of code using the plus signs, using the parentheses, using the division sign that we talked about just now. And I get something really nice like this. So Patchwork, really nice. There are more options out there. This is just the beginning for Patchwork. Finally, to save. So to address the whole thing about, okay, I need it to be a certain size. Maybe it looks squished right here. So you can specify things like that when you do the exporting. And the way to do the exporting is to use this function called ggsave. And so we have our combination of plots. So here's our combination of plots that we had before. I'm just going to assign it to a new variable, a new object called combo_plot. We run that. And here's what I'm going to call that up. So combo_plot to show you what it looks like. It looks like this, right? What we had before. I can call up ggsave, the ggsave function. I specify so I'm going to make this into a PNG. I'm going to specify what I'm going to name this combo_plot.png. Here I'm referencing this particular object, this particular variable that I've assigned this kind of this patchwork set of visualizations. I can specify width in inches, height in inches, and the DPI, the dots per inch. So the standard for printed material, published printed materials is 300 DPI. So this should be in the very end, the set that I see here, this preview that I see here, should be 8x5 at 300 DPI. So you can really, even though you might, change this, it might look distorted, you can get the exact dimensions that you want to fit the page. So here, I'm going to execute this, and you can see that it should save to my working folder. So I'm going to do this. You can see here in the console, it went ahead and executed this. And so I'm going to do the same, except I'm going to create a PDF of this. So same thing, just different format. So I should go back to my, let me see. I'm going to go to show you what I have here in the folder. Let me just go to screen here. And it should be here. Yep. Created just right now. Here's the PNG. Perfect. I think it was 8x5 maybe inches, 300 DPI. It looks pretty good, fairly crisp. And here is the PDF right here of the same exact thing. So everything looks pretty good. So that's how you export things. And there are other formats that you can export in. Here's some documentation here. Here's some documentation for that in this link. You can also obviously, use !GG save. I'm not sure actually, does it? Yep, it does. To kind of get more information, more help here. So I think that's about it. I know this was a ton of information. I wish I had more time to kind of help each one of you out, but I hope you got something out from this and you maybe are a little bit more confident in creating some visualizations in R. Feel free to reach out to me through email if you have more questions or you want more resources. Let me finally, before I kind of open up into any last questions, I want to share with you, where is it? Any other further resources, I think. So some more resources. So there's two, I do have the link here. So there's two websites that are really useful. One is called DataVis Catalog. They're not R specific, but they're very similar to that R gallery. And they divide visualizations by their function. So are you trying to show distribution here? Are you trying to make a comparison, show proportions? Are you trying to visualize some type of concept, movement or flow, etc.? And it allows you to kind of filter based on that. Very similarly, there's a DataVis project. This gives you a lot of other information. It gives you examples. It gives you, I think it gives you some tools. So some of these visualizations are kind of fancy and you might not be able to create them in, say, Excel. And so they'll give you some examples of tools that you can utilize to create some of these visualizations. There's a bunch of others kind of features about them that I won't get into, but kind of explore them on your own. They're very useful. Finally, this chart starter or chart suggestion kind of thought starter is a good place to just get started thinking about, are you trying to make a comparison? Are you trying to show composition? Is it involving some changes over time? Is it static? Does it involve one or more variables or one or more categories? And how to kind of go about thinking what is the best visualization I can utilize for my data set. I have office hours Mondays through Wednesdays, 1 to 5. So if you want to schedule an appointment to take a look at some of your research, some of the visualizations maybe you've created in Excel or R or elsewhere, I'm definitely open to that. And other R resources. So this one last resource, you should have this in the PDF. There are more R workshops from OSU's TDAI. So if I definitely did not cover some of the fundamentals that if you really want to get into R and do the grunt work of cleaning up your data and actually getting it prepped and in the right format and really what you want to be able to explore, you need to understand vectors and data frames and how to mutate your data set and how to do different things to it to get to that point. You have to be comfortable with some of these kind of more complex functions. So check TDAI R workshops. There's one that's really good that's like 4 weeks long, like 1 or 2 hours each week. I teach the last one in that. about visualization, but the other 3 that lead up to that are kind of fundamentals. BDAA, there's a student organization that runs some R workshops that are very good from either students with a lot of knowledge or some professionals in the Columbus area. R Ladies is another one that's great. I think there are lots of OSU grad students who are involved in that. If you want some physical book or something online, there's R for Data Science is very well known by Hadley Wickham, who did he do Tidyverse? I think he designed Tidyverse or created it. And then there's OSU libraries, the O'Reilly or Safari books. So all these O'Reilly books that are for programming, R, etc. There's a bunch of books for R. They're all very good. You can get them for free via OSU's library. And finally, lynda.com. If you are a member of the Columbus Metropolitan Library, and if you're a student, you definitely are automatically, you have access to lynda.com. It's also called LinkedIn Learning right now, to their R tutorials, and I have a link there. So it should be free. Normally it costs money, but it should be free using that link and putting in your library card number. So I've been talking a ton, and if you have questions, ask them away in chat. If you have more questions later on, feel free to email me. Thank you for coming. I should answer some of these questions. So someone is asking about any Python workshops. So we would like to definitely. I mean, Python is really right after R. Python's kind of on our list, but none of us at the Research Commons really is the only person who really knew it kind of left. So we kind of have a void for kind of programming in general. But we're hoping that we can, sometime in the near future, have some type of introductory Python workshop. So someone's asking about, will there be a recording? There will be a recording of this. I mean, the R script that I have, that link that I have that has all the PDFs, the R script is pretty heavily commented. So, I mean, you probably could just read through that and kind of execute the code and follow it along yourself as well. So feel free to utilize that. I'll be here if you have questions. Again, email is fine as well if you have some questions that you think of in the future. But thank you for coming.